Hello again. This is going to be for some of you day 3 of hearing me. Some of you it's the rest of day 1 of hearing me. But hi, I'm Ben Gamble. I am the Chief Talking Officer here at Viverica, and this is my talk about tokens being limited and bringing the right context. Now, normally I do a lot of things about a show of hands, but this stage has a glorious advantage if you're ever nervous as a speaker, which is the lights are so bright that even if my vision was good, I would not be able to see a single one of you. So I'm going to assume there's loads of you in the crowd. So we're going to start with a quote, because you already know who I am. And you might have heard this before, which is, "Those who cannot remember the past are condemned to repeat it." This is a kind of a quote from this famous person called George, whose second name I can't pronounce today, and a very famous painting in the Smithsonian to go with it, about the idea of recreating things over and over again if we don't know how to do them. This is a running theme in software, and particularly if you've worked in the front end, if you've worked in game engines, hell, in data, we're no strangers to it either, which is that we have the bad habit of reinventing the wheel, and we occasionally could do with looking back at it before we do it. Not to say we shouldn't, but to say we should always think about what came before us. So let's remember procedural generation, because currently we're in the age of AI, and you know we're talking a lot about it. I'm sure people are talking to you a lot about it. And if you go back a few years, I used to work in game development. And procedural generation, particularly if you are older than a certain point, was the way most games were made, and still some are. It's a skeleton we wrap in meaning. This is from a game called Rogue. Rogue came out in the 80s and was the first of what spawned the roguelike genre. This is the idea of saying your game can be generated from near true random numbers. You have a bunch of seeds and a way to generate rooms. This is a BSP, where binary space partitioning happens, and then they basically connect up the rooms to build this dungeon, which is ever evolving and is never the same again. Except in the original Rogue, you can find the source code, the random number generator is bad. You can really easily get the same setup again. It doesn't take that long. But the idea is simple. We generate just enough to give you the idea of narrative. And then later down the line, something called Elite came out. Actually built very close to where I live in Cambridge. Elite was a game where it was the first game to kind of display a whole universe to you. And even way back then, when it ran on the ZX Spectrum and things like that, it had the ability to kind of portray whole worlds and give you this feeling of generation. There's a famous thing in it known as the goat soup algorithm, where it generated a description for a planet out of this kind of truth table and a bit of a random dice roll weighted in certain directions for some kinds of planets. And it gave you this kind of impression of life, that it was always different. But there was kind of, the joke came from the fact that many planets were famed for their goat soup. And if you've used AI these days, the word delve pops up a lot. And this is kind of the precursor to that, when the algorithm is slightly too heavily weighted in one way or another. And the problem here is the narratives are simple, and there's a limited number of variables, because these had to be hard-coded onto tapes or floppy disks back in the day. Now, the modern limitations are a bit different, and you're probably wondering why I'm going down this odd tangent about now. But it all comes back to the same thing. And these things aren't good enough for small children. See, I have 2 small children. I also have 3 pet ducks, and I often try to tell them stories. And if you've ever tried to tell children stories and they've enjoyed one book, they'll ask for the next one, and the next one, and you will run out. And when they ask for, "We want Aladdin to go on adventures with Pokemon," the challenge gets rather hard. You can do the first, night stories, 5 minutes of making stuff up, but the next night, they'll remember what happened. And these books are my son's favorites right now. They are astrosaurs. It's basically like the Starship Enterprise light done with dinosaurs in space. And there's loads of them. But the problem is that the local library only has so many. He gets bought 1 or 2 every now and again, but we've definitely hit the limit of what we can easily get hold of. And when he wants a new Astrosaurs adventure, what do? So I turned to AI, because you know what? It was in my pocket at the time, and I thought, screw it, let's see what happens. It might even know the story. It did know who some of the characters were, and it made up some new ones. It was quite good fun. The thing is, right, there are so many AI agents. So I can just about see things now as my eyes are a bit adapted. Hands up here who's used OpenAI. That's, I'd say, all but about 2 people over there. Hands up here who's used Claude. Hands up here who's used more than 2 of the other ones remaining on this. We've pretty much done the whole loop, haven't we? We've done, this is great, it stopped working, next one. Or I ran out of free tokens, next one, which is my tend to have it here, is because at least at the beginning when I started using these, I didn't have a corporate budget behind me. So I went through every single one of these in order. Like currently, Grok is free on Cursor, so I've abused it to the 9s. So they can do all kinds of cool stuff. And this is where I kind of started, because if this was a kind of a joke of me demonstrating to a friend what it can generate. And hands up here who's familiar with Pride and Prejudice, the story from Jane Austen. Few of you, old story, period costume drama. It's kind of like quite famous, at least in the UK. But you know what? I want to try and mix it with Jason Bourne. So Mr. Darcy, the main character, the love interest, if you've seen Bridget Jones's Diary, that's one of the who's based on this story. And I said, what happens if you mix it with Jason Bourne and kind of blend the 2 plots and see what happens? And the answer is, you get characters, a Mr. Darcy version of Jason Bourne. He wakes up in the Thames with no real memory of who he is, with strange skills. The setting is Regency England, but it's a Napoleonic Cold War now rather than a hot war, because then we have spies. So we had to adjust some things. It's quite powerful. And the plot is, it's period drama Jason Bourne, but because he's British, he acts more like James Bond. And this shows the kind of the ability of these LLMs to kind of pull context from various places. And if you want to read the first bit, this is just a gist on my GitHub where I've dumped the first bit of the thing it output. I then proceed to generate a bunch more, but the first bit actually kind of hits the notes quite nicely. So this is just a link to a GitHub gist of the first chapter of the story. And what is really important here is that everything starts really well. Like if you've used AI for anything, the first few experiences feel really good. They feel really solid. And what happens is, as you go through the experiences, you think, this is great, it can just keep going. But it tends to forget detail incredibly quickly. And it doesn't take very long for you to realize that it doesn't really have a memory in the same way you'd want it to. Even when you're just talking to it normally on like a ChatGPT chat, you're normally not too bad, but if you go back a little while when it was still 3.5, it would normally take 3 or 4 messages before it started losing context. With 4, it got a lot better. With 5, it's fairly good if you've enabled memory, but you'll still start to see it lose detail, wander off plot, or have no ability to jump back to it without you resharing the context as it goes along. But that's just the chat experience. When you dive into trying to do mechanical processes with things, it gets bad much faster. And particularly when you're like driving it with code, like using the coding bots, I rapidly find I have to remind it to do 0 copy more often than not. I have to have 4 or 5 different rules telling it to use UV to install my Python rather than just pip, because pip doesn't work on my machine. For reasons I have yet to understand, I think it might be me. I might have done something. But the number of times I've had to be explicit in either my Claude file, my Cursor files, or everything else, shows very clearly that when the context starts getting large, it doesn't know what to do next. So the first thing you do is, can we scale up the model? Because particularly when you're dealing in code, you can start ramping up the context windows. And as I said, we all started doing this a year ago or so now. And it starts great. You keep scaling, you keep going, you pay more, and we start to hit this edge, and the crash happens. Basically, the context goes and smashes into the wall, and you're losing something. It looks like it if you're on the front 3 cars, everything's great. But as you ramp up the context, something spills over the edge. And this is where we end up in this kind of open question of, what can we actually do with it? And this is what you'll see particularly in Claude. Claude has this the worst as a chatbot. Like even the max thing I'm currently paying for, you'll hit max length of conversation, hard limit. Claude tries not to forget. And there are a few different options you run into here. The first one is, we do not allow you to forget, so we'll just stop. Claude Code says compact. But what is quite fascinating is, if you try and do a manual compaction, it will often fail, because it can't understand sometimes when you want to compact versus when it wants to compact. And this is where we get to the real problem here. It's like, if you let it compact itself, and make guesses, you have non-determinism because you don't know what it thinks is important. This is where the idea of full control comes in. And as the rest of this talk continues, I'm going to go into more detail about more and more control. This talk is separated basically into a premise and then some code to go with it. So why does this matter? And particularly when I go back to dealing with stories by children's plot holes. And if you ever watch Rick and Morty, these are the various characters. And the last one in the bottom left on your screen is what's the character known as Brett Kahn, who changes history by saying, it has always been true that something is something. And this is what the AI tends to do. It basically just thinks, oh no, that's true. It's definitely true. And it'll try and increasingly convince you of something which isn't true. Now, a chatbot, this is kind of bad. And my personal example of this was, I asked it, do I need a visa waiver to go through the US if I'm transiting the US? It continuously now thinks that you don't need one. That hasn't been true in 15 years. It's just that there's so much material out there that it's convinced itself it's true, and even contradictory information it assumes is wrong. And it's incredibly difficult to convince the pre-trained models to do something they're not supposed to do, particularly with the way their context windows work. So we need more control. And this is where, for the next bit, we're going to talk about things with code. It's time to manage the context windows ourselves. The default LLM structure, of course, is you throw text in, there's some processing, some reasoning, some generation, and text comes out. And this is where the token limits hit. There's a defined number of tokens you can throw in. And the more and more you add, the more dilute they get. And this is kind of an open problem, which is more tokens doesn't mean better answers. So instead, we're going to start putting some contextual input in. This is those control things. Now, a thing you have to know at this point is your system prompt is still part of your context window. A lot of folks and a lot of systems increase the size of the system prompt to try and direct the AI to act in a specific way. You are still paying for that in your maximum context window. The other half of this is external data. This is often referred to as RAG, or Recall Augmented Generation, where we fetch data from something. It's important to note that this doesn't have to be a vector database. This can be anything. This could simply be a SQL query. It could be an old school BM25 search. It can be literally an inverted index lookup. It doesn't matter. It's still recalling something and putting it in. So now let's think about some of the data types along the way. So we're going to start with something start with the simple things in the data structure. So I'm going to start with some Python. I'm going to try and pull apart a book. Where do I start? Well, in this particular example, I'm starting with fanfic.net because I want text I can find and I want it in a parsable format. Because we're going to generate a novel here. So we're going to find some free novels we can pull apart and then generate things based on those. Why we're using novels here is because we're trying to hit one of those interesting circumstances where it's very obvious when it's failed. As humans, we're very good at telling when stories are inconsistent. Listen to your child when they explain why they've done something wrong, and you'll see all the plot holes very quickly. But more importantly, most stories have to be cohesive. If you've ever tried to read a technical explanation from something, you often do not have enough context to know if it's right or wrong before you check the source material. If you ask it to tell a story, it's really quick to see, well, that character wasn't there before, they've never been introduced. You can feel it very quickly. So it's been the challenge I always set for the AI systems I build is, can I make a story? And then can I pull apart a story? So we're going to do this with Python and some OpenAI. We're going to parse up a fanfic and build up a knowledge base. Because the first thing you want to do when you generate a story is know what characters there exist. So we're going to find all the characters who exist in the existing corpus and then pass them forward. We're going to both train and learn at the same time. So we're going to generate some information, train the next recall, and go forwards. Let's see what V1 generated. So I chose something called Harry Potter and the Methods of Rationality. Now, hands up who's read Harry Potter, or knows the story at least. Hands up who's familiar with this specific piece of fanfic. Anyone? Now, the fanfic at face value is kind of fun. It's the idea of Harry Potter was raised by a professor of rational theory in Oxford rather than being raised by a relatively cruel family of materialists. Hence, he's a very big believer of the scientific method, and he proceeds to have a rather chaotic version of adventures. imagine you applied a little too much rationality to Harry Potter, and this is where you go to. So, now we're going to jump into a variety of code. As you can see, I play too many times with these things. So, as you start pulling apart the thing, a story like this, you generate a vast quantity of JSON. And as you notice, it's impossible to read. So eventually you say, let's put it into a database. Apologies, everything closed the minute I put it on screen, and I had to reset all my screens. So this was on screen, but is now not. Here we go. So let's look at characters. So in characters, we have, I'll make this in a much more visible fashion now. View mode. My apologies, my eyes are bad and I occasionally miss where the buttons go. Here we go, into presentation mode. So, the characters in this thing are sort of who you'd expect. We have Harry Potter, who goes by Harry James Potter Evans Verris. But as we scroll down here, you'll find that Harry Potter as just Harry Potter comes up as the second character, because the AI doesn't know the difference between them. And this is where you come into the kind of logical inconsistencies of what an AI reads things as. Now, this is the problem with just using an LLM. And every time you try and use just an LLM as part of your toolkit, you're going to run into the edges of the only things LLMs are good for is one or two very specific things. They speak human and machine, and they can translate between the two. They're not great at what's known as named entity recognition. On the other hand, there are amazing algorithms at named entity recognition that exist out there, and they run really quick because they're pre-optimized, pre-trained neural nets. And as you scroll through the various characters, right, you can effectively have code that just pulls through and keeps amalgamating what happens. So this piece of work is a few million words, and it went through it all overnight and effectively crunched through and generated all of the various things. The problem is that over time, stories change, and who a character is as their character arc goes through makes it very difficult. And this is where you run into the next kind of interesting problem with generating anything is the truth changes. So who here has dealt with an AI giving them information which was out of date? If you ask Claude for something, like even today, it still thinks it's 2024. It's quite fascinating. This was this morning when I was just testing this. I asked it what year I did something. It said, find me a library for something, and it said, searching so-and-so, 2024. Now, I'd understand that from a perspective of finding a stable code library, but not from the perspective of it's October. I'd expect something from this year. So this is where we run into the kind of the first problem of you can't rely on an AI to feed itself. And after I kind of got this far into it, I thought, let's try and see what we can do next. So, the presentation. This is what you always come back to. Now, who's familiar with what movie this came from? This comes from a movie called I, Robot, and an amazing book by Philip K. Dick, which is even more interesting, if considerably weirder. This is a little chat symbol given to the main character, played by Will Smith, and it basically he asked it a question, and it kept saying, my responses are limited, you must ask the right questions. And this is the thing where, like, if you give the AI the right context, and if you're doing this from code, you have full control of the context, you can get the answers you want, or at least a version of them. So let's talk about how we fixed the problem we had. To start with, we need historic data. This is, as you saw earlier, the pre-parsed example of what happened. So when I started improving the parser for the stories, and also for everything else I do now, you feed past data in. This is kind of context information. Next thing you need is live data. This is the actual question or thing you're asking for. Now, this sounds obvious, yes, but it's just setting the stage for what's next. This is where some math is applied, because the real problem right now is there is too much historic data and there's probably too much live data. And this is where we've got to start applying things. Otherwise, we're going to hit max context again. Because unless we can crush the context down to being the relevant pieces of information for what we're doing at the right time, it doesn't matter. We'll just lose half of it. And we need to do this as fast as we can. Because if we don't do it quickly, we're kind of losing the point. Otherwise, once again, you may as well have a human in the loop defining what's going on. Let's work through it. This is called structure-aware compaction. There are a few different techniques along the way here. I have a longish list. Now, information extraction in two triples. RDF triple stores have been around for a very long time. I have inconclusive evidence of when they were created, so I'm simply going to go with a long time. This is the idea of a subject, a relation, and an object. And it basically has the idea of a thing like Ben works with Jaime, who's over there in the audience, right? Works with Dawn, who's also next to Jaime. You know, has given a lot of talks to you folks in the middle who had to listen to my long, long, long workshop. And these are really valuable because they're a statement of the truth. And this is what you call a knowledge graph. It's Sparkle queries to find them, ontologies to classify them, and your agents to bring them all together and in the LLM bind them. Yes, I will tell terrible jokes along the way. And the key thing here is that an ontology is a classification tree. It basically says that a car is a vehicle, because that's a thing we know in advance. And by applying these known grids of information against the information we've given them, which is our triples, we can start to basically have knowledge pre-baked in the system. Hands up here who's heard of graph RAG, or graph recall augmented generation. Hands up who if it was a property graph, or hands up who was a knowledge graph. So you actually managed to do Sparkle queries for this, yes? Okay, cool. So the thing is, you'll mostly find with this stuff is, most of the time, people at Neo4j are out there talking about property graphs. Property graphs are cool. They solve a lot of the classic graph theory questions, but RDF triple stores are what we want for this one. This is where we know the relationship between things, because the relationship matters more than the fact in most cases. The next thing we're going to do is talk about putting things together and distillation, right? You pull out entities, fields, and metrics into a compact format, right? You only want the things you need. So this is where you're building up the truth tables. So this is why we need multi-formatted data. Knowledge graphs are great because they'll tell you what is true. This is telling you what is true for you today. And then you have to then do the split up. There's different kinds of memory. There's a famous thing called long-term, short-term memory in most deep learning circles. And this is true regardless, because fundamentally, the large language model is basically just a neural net. And have you ever done a feed-forward neural net where your data goes background and background and background? You have to have the ability to forget some things along the way. Episodic memory, recent steps, and semantic memory, long-term facts, knowledge graph. The procedural, which is your combination of your meta prompt, which is really important. You have to keep these things in different kinds of stores, and more importantly, add them at different points in the journey. Because what we really need is determinism. Because hallucinations are not good for business. They're funny for a children's story. Don't get me wrong, I ramp the temperature right all the way up for a children's story. It makes it genuinely funny when suddenly Aladdin and Jasmine, who are capturing Pokemon, are now doing it in space. This is a genuine thing. I can show you the story. But it's not great when you're trying to do a business process, and even worse when it's an agent. Low marginal cost. Now, some of this, who were in the training yesterday, saw me say a bit of this along the way. But the key thing here is that if something is good, you'll want to do it more. And if it starts costing too much, no one's going to like it. The problem with AI is it promises either a saving or a capability add, but if the marginal cost is too high, the question comes, but we could do it before. There's the famous thing is we have McDonald's at home, is the phrase we often get, that if you do not meet the marginal cost requirements, business says no. And of course, the other half of this is scalability. Now, a lot of you are working with Apache Flink, I'd assume, yes? Cool. So Flink is really good when things are big. So hands up here is allowed to build a non-scalable solution. Oh, that's a resounding nobody. Brilliant. And it means you have to have it scaling. And this is where fault tolerance comes in, because systems fail, especially third-party ones. I know OpenAI goes down more often than they care to admit. They've given some great talks about how they do resiliency, but their APIs get thrashed so hard it's crazy. But also, Now, these are non-deterministic systems. They return bad JSON so often it hurts. Let's talk about Flink agents. Now, this is where we start chaining tasks together. This morning you heard about Flink agents being released into the public. Now, I have spent this morning frantically rebuilding a demo on the official version of Flink agents because, one, it's quite a good framework, but two, I built the first version of this demo 3 months ago because for once I planned ahead. But it's now working on this. And this is where the idea of being able to sort out messages with Flink ahead of time, deploy the agents in various languages and capabilities, and then collect and loop results and serve them. And then I made the mistake of trying to formalize all of these into some structural stuff. So this is where we're going to go back into the code. And this is actually all going to be open source because I know for a fact that reading code on screen or seeing demos on screen can be a bit far away and not touchable. So for this, I have built a getting started guide and a full set of examples with the whole Flink agent thing running on Olama. This uses a combination of side channels, CEP, and Flink agents to give you the ability to have multiple loops of data going around in a circle. If I try and jump to the README file and render it, the GitHub will be shared at the end. We're basically going to be using a series of features, including a context manager, which I've built myself. And the hybrid architecture between something I built and not, it comes with all of the usual kit and will run locally on your machine. The idea is simple. You need to have the various agents. So you normally have one that reasons, one that checks, one that confirms, and other things. And what we're using here is complex event processing to route between the various pieces along the way and say, hey, this is an event that says generated. Is it good enough? Side channel, back, refer, forwards. I will now, because those of you who are now putting your phones to take pictures, let's give you access to the code now. So this is called Agentic Flink. There is 2 versions. The newest branch, which is the second one, which I think I've pushed, is the one that has the official Flink agents library. The first one is my Flink agents library. I recommend the official. The official actually has proper debugging attached. So this is the QR code. Hopefully that's big enough for you to see, but I will make it bigger again. This is the library for it. There's a full set of examples in there of how to use Flink agents, along with how to make them roll in Flink. The idea here is you want a decision tree for anything to go through in single-digit milliseconds. This runs end-to-end outside of the LLM calls in about 0.6 milliseconds, doing all the decision as fast as possible. It'll maintain memory inside Flink, calls out to Qdrant for RAG, some of the RAG services, and uses Redis in addition for additional caching outside. Broadcast state is used to allow you to change the system prompts across all the agentic calls at the same time. And anyone who was in my training is now going, we heard all this yesterday. And the answer is, yes, you did, and I did warn you. Yes, you were warned. The goal here is simple. The AI is going to get better and better and better, which is great, but your data is still going to require some level of filtering to get on board with it. Unless we can basically control that end-to-end flow correctly, you're going to end up in a situation where you don't have control anymore. With this to date, I've probably generated another 3 books for my children, and if you'd like to see some more of what kind of text generation you can do at the end of it, or have access to the ultra-detailed Python version of this is the Java one, which has every single piece of NLP tech I know about built in, I will also share that at the end. I am easily findable for the rest of the day, as I'll probably be at our booth, and definitely around tomorrow again. But thank you very much for listening.